Hi, my name is Mohammed Chaudhry. I will be presenting today on sentiment and emotional analysis, which is a fascinating piece of technology in the field of natural language processing that allows machines to understand human emotions and sentiment from text. Have you ever posted a review on Amazon, tweeted your thoughts on X, or left feedback on his website regarding a product that you just bought or service that you just subscribed to? Companies analyze this data in real time to understand a customer sentiment so that they can make feedback to use it to improve their product and services. Is it positive, negative, neutral? Going further, emotional analysis can even detect specific feelings like happiness, anger, or sadness. Today, we'll cover what sentiment and emotional analysis are, why they're important, challenges in detecting sentiment and emotions accurately, popular tools that are used for analysis, real world applications and future trends, and also much more. By the end of this talk, you'll know how AI can understand and interpret emotions. So, what exactly is sentiment and emotional analysis? Well, so so sentiment analysis, which is also called opinion mining, is a field in natural language processing or NLP that helps computers determine the emotional tone behind a piece of text. It classifies opinions into three categories: positive sentiment. An example is "I love this phone; it's amazing." Negative sentiment. Example is "This movie was terrible, waste of time." Neutral sentiment, which is an example of this is "The weather is fine today." And emotional analysis is a deeper subset of sentiment analysis. Well, sentiment analysis it classifies emotions broadly. Emotional analysis goes deeper. Instead of just positive, negative, or neutral, it detects specific emotions such as happiness, anger, sadness, surprise, and fear. Emotional analysis is useful in mental health, psychology, and customer experience research. For example, it can detect anger from social media users at a politician's new policy or proposal in social media posts, which can be helpful than just algorithms picking up that it's a negative sentiment, because anger and fear are both negative sentiments, because it's better to understand the actual emotion behind the text. Why did I choose this topic? So I'm going for a master's in AI, so I thought that would make sense that I would make a presentation based on sentiment analysis, because I think it's a very useful part in AI. So that's kind of why I decided to choose this topic, and also I was very interested in it. And also, I think that this topic has a far-reaching impacts in all areas of our lives, from medical to media, to everyday usage by people. So that's kind of why I chose to do this product today. So how does sentiment analysis actually work? Let's break down how it actually works underneath the hood. Sentiment analysis is a key application of natural language processing, which is further a branch of AI that helps computers understand human language. So let's go to more into a step-by-step analysis to the process to understand how sentiment analysis actually works. Before AI can even analyze sentiment, the text must be cleaned and prepared. Pre-processing techniques include removing punctuation and special characters, like "wow" with exclamation points are turned into "wow" with no exclamation points, and lowercasing all words like "great" to "great." So, and the next step would be feature extraction, which means you're turning text into numbers. AI doesn't understand text; it only basically works with numbers. And so we convert words into numerical representation using techniques like BOW, or bag of words, which counts the number of words in the text. TF-IDF, which is called term frequency and inverse document frequency, which weighs the actual important words, and word embedding, like BERT, which converts the word into meaningful vectors, which are further created or multiplied and added in computation, so we can get the output result. So word embedding, for example, happy would be given certain numbers like zero point 0.8, zero point 0.2, negative zero point 0.5, etc. And sad would be given certain amount of numbers. Words with similar meanings have similar vector values, helping AI understand the relationship between the two words. Which means like synonyms would have similar vector results. So how does it work continued? The next step would be sentiment analysis. So sentiment classification. So once text is converted into actual numbers, we train with sentiment classifier. So models can fall into two broad categories: machine learning based sentiment analysis, which uses traditional ML models like logistic regression, naive Bayes, support vector machines, and then these models can learn patterns from labeled trading data, so positive and negative tweets. It also uses deep learning based sentiment analysis. So it uses neural networks and advanced AI models like RNNs, or recurrent neural networks, to capture long term dependencies in text. It also has transformers like BERT or GPT-3 and 4, which understands word context better than than older models. So a sentence, "Oh great, another Monday," a deep learning model can correctly understand the context and detect sarcasm correctly, unlike the more traditional models, which only has one layer of neurons. And the next step and final step is the sentiment scoring and output interpretation. So we use two main Python libraries called TextBlob or Vader, which generate a sentiment score. From TextBlob, it's a -1, which is the most negative value or sentiment, or +1, which is a +1, which means the text has the most positive value. And Vader also has a compound score ranging from -1 to +1 as well. So an example of this is that if the text is "this phone is great but the battery life is terrible," Vader will output the positive score is 0.4, negative score is 0.5. So that means the compound score would be -0.1, so which means that sentence is slightly negative. If the score is highly positive, the system labels the review as positive. If it's low, it's going to be labeled negative. Sentiment analysis is powered by natural language processing, machine learning, and deep learning. By processing text, converting it into numbers, training AI models, and classifying sentiment, we can extract valuable insight from the human language and from text that we see, and we are to use them to get an output of what the text actually means. So let's look at some real-world case studies. So one of them is Netflix, which has personal recommendations. So Netflix uses sentiment analysis on user reviews and feedback to improve movie recommendations to users. They analyze tweets and reviews to see how audiences react to new content. If a new show receives negative sentiment, Netflix may promote other content instead to the user. So, for example, the show Squid Game is gained massive amounts of popularity due to viral global sentiment on social media like X and Instagram, leading to global marketing efforts to push Squid Game, for example. Another example is financial market predictions. So, hedge funds and investors use AI-powered sentiment analysis and emotion analysis to predict stock market trends. So they analyze news articles, earning reports, and tweets to determine if the stock sentiment is bullish or positive, or bearish, which is negative. So, for example, Elon Musk tweet about Tesla, which is his own company, have led to massive stock fluctuations. Because if he says something negative, then it means that, oh, well, the stock may go down. If he says something good about it, oh, the stock may go up, for example. The next one would be Amazon and its product review sentiment for sales optimization. Amazon uses sentiment analysis on product reviews to rank search results. Products with high positive sentiment appear higher in search rankings. So, for example, if a laptop or a computer gets negative sentiment due to battery issues or bad audio issues, Amazon may lower its ranking and flag a product for review. These case studies show that sentiment analysis is not just a theory, it's actively used in business, finance, and public health to make better decisions. Sentiment analysis has played a major role in advancing the field of NLP. The need to understand human emotions through text has driven research in text analysis, machine learning, and deep learning. The word embedding and sentiment-aware representations. The demand for better word detection has led to word embeddings like GLOVE and fast text, which encode words as vectors based off meaning. This has allowed NLP to capture relationships between words, which is a major step forward. Word embeddings allow AI to understand that happy and joyful have similar meanings and are synonyms, while happy and angry are opposites and are antonyms and have different meanings. This has improved sentiment detection significantly. Another development of BERT and GPT is the context-aware language models. So, because of these transformer-based models, sentiment analysis has required NLP to go beyond single words and understand entire sentences in context, which is much better for understanding text. This has led to breakthrough models like GPT, or Generative Pre-trained Transformer, which learns a large-scale text data and generates more human-like responses. Or BERT, which is called Bidirectional Encoded Representation from Transformers, which reads sentences both ways to capture full meaning. So both BERT and GPT can understand the context better, allowing AI to detect sarcasm, humor, and emotional subtleties. AI-powered chatbots and emotionally intelligent assistants. As sentiment analysis has improved, it has contributed to the rise of emotionally aware chatbots and virtual assistants. AI assistants like Siri, Alexa, and GPT are now using sentiment-aware responses to engage in users more naturally. For example, if a user says, "I'm feeling sad and lonely," future AI models will adjust their tone and respond with empathy instead of a generic reply. Customer service chatbots now detect angry customers and escalate issues automatically. Challenges in sentiment analysis. While sentiment analysis is a powerful tool on its own, it is far from perfect. There are several core challenges that make understanding emotion through language incredibly complex, especially for machines. Let's look at some key obstacles that researchers are working on. Understanding context. Language is contextual. Words mean different things depending on how they're used. Take the phrase "that's sick." In one context, it can mean that somebody is physically ill, which are negative, or another, in slang, it can mean it's awesome or cool, which is positive, of course. So if the basic sentiment model might classify sick as negative, usually without understanding the full sentence or speaker's intent, because most of the time it probably will mean that they're physically sick. So why it matters? If businesses use sentiment analysis, might misinterpret feedback if the context is not understood properly, leading to poor decisions or necessary escalation. So, for example, if a bunch of people said that this product, this new food makes you, they say this is sick, they may think it means that it makes them sick, for example, which may make the product more appear negative as an output or positive instead of positive. Another one is sarcasm and irony. Sarcasm is notoriously difficult for AI to detect because it relies on tone, implication, and sometimes contradictions. An example is that, "Oh great, it's great, my car broke down." The sentence contains the word "great," which may mean positive, but within context, it clearly means that you're basically expressing dread and annoyance because your car broke down, of course. So sarcasm is obviously very common in YouTube comments, Twitter, and Reddit. So if AI basically takes these statements at face value, it can completely misclassify an emotional tone. And also another problem is multilingual challenges. Many sentiment analysis tools are English specific, but if a user speaks in, for example, Spanish, Arabic, Hindi, or some kind of mixed language, um, a simple model may not be able to grasp the nuances or idiomatic phrases across the languages. Global platforms like Facebook, YouTube, and TikTok has content in hundreds of languages, dialects, and styles, so which means that it's very difficult for AI to kind of detect these or text sometimes. But there are many ways that these models can actually fix these issues. Like an example is that traditional sentiment analysis can now understand the full context of a sentence by using models like GPT and BERT, which understands the context of the whole conversation. So, for example, if the term "that's sick" in isolation it sounds bad, but AI can look at the surrounding conversation to figure out if it really means sick means cool or bad in a negative or positive way. It can also detect sarcasm and irony by using emotional infused AI, which uses emotional detection models to analyze text, tone, punctuation, and user history to better understand sarcasm. So an example is if like AI looks for exaggeration or negative words together, like, "Oh wow, that's just what I needed, another delay in my train." If exaggeration is present, AI flags it as possible sarcasm. And also emojis and punctuation probably makes it more likely that's sarcasm in the AI's point of view. And also for multilingual sentiment analysis, sentiment analysis struggles with different languages, but AI models like cross-lingual models are trained in multiple languages, which makes it better at detecting sentiment across cultures and different languages. Google Translate is being improved to capture the tone of sentences, not just direct word translations. And also another example is that AI learns from cultural nuances. So a phrase like "it's interesting," which may mean bad in Japan, is correctly interpreted based off of the language and trends of the current nation or culture. So some future trends in sentiment analysis is that AI-powered emotional detection it's going beyond text, and it's going into text, voice, and facial expressions. So what this means is that AI will combine speech, tone, and facial expressions to detect true emotions more accurately. So call centers can use customer words and voice tone to detect frustration, That a customer if sounds angry, this system can escalate that and give the call to a human agent much faster. And another example is, of course, that for multilingual models is that future AI models can better detect slang, understand regional expressions, and cultural sentiment differences. So AI can now understand the subtle cultural cues that will interpret emotions correctly depending on the culture. And emotional AI is used in mental health and well-being, so that future analysis tools will assist mental health professionals by detecting depression, anxiety, or stress in online posts and messages. So that mental health chatbots will analyze users' text for early warnings and signs of depression. Universities and workplaces could use sentiment analysis to identify stressed individuals based on email tone and offer support. Some popular tools for sentiment analysis is that is that basically human emotions can be handled in text, and that there are great examples that are Python based that can definitely help users in this. TextPlot, for example, is a beginning friendly user library that is built on top of NLTK and Pattern, which uses rule based sentiment analysis that assigns a polarity score between -1 and +1. And it's great for basic tasks like analyzing customer reviews or survey sentiment. But it may miss nuances like sarcasm or context. Vader is a lexicon and rule-based sentiment analysis tool built specifically for social media post texts like Reddit and to X. So it's included within NLTK, and it can perform well with slang, emojis, and exclamation marks. It outputs as a compound score of positive, negative, neutral, and compound, which combines everything into a single score of -1 to +1. It's very lightweight, fast, and actually effective. And also, modern deep learning models like BERT, GPT are currently being used a lot within NLP and this topic because GPT is very generative, and it can also predict sentiment based off of what the user is talking about, but it's not always fine tuned for the task. But these models like GPT and BERT can handle complex expressions, sarcasm, and multi-sentence reasoning much better than traditional tools. But they require usually more computational power and data. So in conclusion, sentiment analysis helps machine learning helps machine learnings understand human emotions through text. It's a core application in natural language processing, and is powered by AI, machine learning, and deep learning tools like TextPlot and Vader to provide a quick, accessible sentiment analysis for a bunch of real-world cases like healthcare and legal. So it provides a lot of value to many professions in many fields. There are a lot of challenges like sarcasm, context, slang, and multilingual input, but AI models can be tweaked to understand user inputs and be better in the future. So that while sentiment analysis and emotional analysis is of course a growing field, there's many opportunities to make the models much better and tweak them so that they can be used by lots of people and to have a better output. And so that's kind of the end of my presentation. So thank you for kind of listening and to my presentation on sentiment analysis. I hope you have a wonderful day. Bye.